So we are on section 11.3, which is called the tangent line problem. Brady, wake up. Say it again, Jane.
The stuff where we wrote like the interior tangent line problem, like what you just did, was that 11.32?
Yes. Okay, so you guys took down some notes the other day with a graph and f of a and f of a plus h, and that's stuff that I do want you to be able to kind of briefly summarize back to me. So we'll do that again. Basically, what you guys encountered the other day is the limit as h approaches 0 of f of a plus h minus f of a all over h. This is called a derivative. Okay? We're going to write down another definition. So I told you guys briefly that when we find this derivative, it's the slope of a tangent line. Okay, but we need to write that down formally. So go ahead and do this. The slope m of a graph. So we're not, when I say a graph, it doesn't mean that it has to be a line. It can be any graph. At a point, the point is x and then f of x. So that tells you a couple things. Your graph is a function because we're using function notation. And this is your x value and this is your output value at x. Okay, so the slope m of a graph at a point is equal to the slope of its tangent line. At that point. So at x, f of x. So this is m. So one of your first questions on your homework will be to estimate the slope of the tangent line. So if I give you an upside down parabola like this, or any function, this is y, this is x, this is f of x. I have to pause for just a minute. I forgot I was saying. Okay, so our job is to estimate the slope of a tangent line at any point on this graph, okay? And I'm not really concerned with the value of your slope, but if we put a point right here and then envision a tangent line to that point, so a tangent line to that curve, what could we estimate this slope as? Do we know if it's positive or negative? Positive. And without knowing any numbers on this graph, we could just make sure that we said it was like +4 or something like that, okay? Mostly I care about if you know if it's positive or negative, all right? Now this one you should know. If I put a point right here, the tangent line will be what? Horizontal. So what's the slope? Slope of that one would be 0. Those are the kind of things that we're most concerned with when we're just estimating. So then if we did another one and we put a point down here and created a tangent line, right, you have to know that this slope would be negative. You know, it looks like it's a little bit steeper than this one, so maybe I'd put a -5 just to make me feel better. Okay, but you're really just kind of creating some number. Okay, so here is your here are your first two examples, and I think that you need to read the entire directions. So we're going to copy them all down so that you know what they're asking for. So we're going to find the slope of f of x equals x squared at -2, 4. Bless you. Then we're going to find the equation of the tangent line at negative 2, 4. Finally, we're going to graph the function and tangent line. That's a lot of stuff. You don't have very many of these to do. But this is it. This is what you're going to do. This is basically the first half of calculus. Okay, so we know that the slope equals the limit as h approaches 0 of f of a plus h. You know what? I want you to use x's instead of a's. It doesn't matter. F of x plus h minus f of x all over h. Okay, and I know that you guys feel pretty comfortable with doing that difference quotient. Okay, now the difference is that this time we know what x is. What's our x value? Okay, so that's kind of the key piece here, is that we know that x equals negative 2. Now, there's two different ways to do this, and I'm just going to go with the way that the book does it and see if you guys can hang with it. Limit as h approaches 0, f of, instead of having an x here, I'm going to put a negative 2 plus h. Minus f of negative 2 all over h. Okay, do you see how it kind of changed a little bit? We're not using all variables. We actually have a number that's going in there. So this is still step 1, this is still step 2, and this is still step 3. So let's go over here and do step 1. I want you to evaluate f of negative 2 plus h. So if we know our function is f of x equals x squared, then instead of having an x here, what am I going to replace it with? Negative 2 plus h squared. Okay, now I can't really move over here, but these two things are the same. X is x squared. Negative 2 plus h is negative 2 plus h squared. Okay, I'm not going to try and move anymore. That was dumb. Okay, so go ahead and FOIL. Okay, so that would be, first would be 4, then minus 2h and minus 2h would be minus 4h, and then plus h squared. Okay, I would go ahead and do step 2, because it is going to be a little bit different than last time. It's not just f of x. So f of negative 2 would mean take this function and put negative 2 in here, squared. What do you get? 4. And now you can go ahead and evaluate your limit situation. You ready? Okay, so now that we've done all this stuff on the left, we're going to go ahead and substitute over here. So m equals, I like the m there because it reminds me that I'm finding a slope. The limit as h approaches 0, our f of negative 2 plus h, or step 1, is right here. So it would be 4 minus 4h plus h squared. Abby, what would my next symbol be? Minus. And then I need to subtract f of negative 2, which is 4, all over h. Things should go away. If they don't go away, you've made a mistake somewhere. So what are some things that cancel, Tori? Oh, she's yawning. I caught her right in the middle of a yawn. 4 and negative 4. And then, Olivia, what else happens? What else goes away? Not an h squared, but one of the h's. Right. Each of these two terms have an h in them, so you can divide. So this one goes away, one of these goes away, and this goes away. So m equals the limit as h approaches 0 of negative 4h, no, sorry, negative 4 plus h. Okay, this is a step that you guys need to go ahead and finish. So you're supposed to say h can equal 0 now, so m equals what? Negative 4. Okay, we've done part 1, which was find the slope. What's part 2? Okay, so go over here and make a little box about equations of lines. Just to remind you from, gosh, 7th grade? This is when you first learned this stuff. So what's one equation of a line? Who wants to tell me? Michael. Yeah, that's the equation that you use the most. I don't think we'll use it here. Okay, it's probably not the best one to use here. That one is most useful for graphing. Okay, this is your best equation for graphing. Okay, the next one. Who knows another one? Point slope form. Y minus. Okay, this is the one that we're probably going to use the most. It's called point slope form. And then what's the formula for President Obama? AX equals C. Okay, that's standard form, and that's just pretty. Well, if you were going to go up to President Obama and you're going to talk about lines, you would want to give him the most formal of the three, which is standard form. It's just a formal situation. No. Okay, so the equation of the tangent line. We're going to use y minus y sub 1 equals m times x minus x sub 1. In order to use this format, you need to identify m. Do you know m? What does m equal? -4. What else do you need? A point, x1 and y1. X sub 1, y sub 1. Were we given a point? Yeah. And even if we weren't given a point, you could find one. You could make a table just based upon what the function is. But we know that our x sub 1 and y sub 1 is -2, 4. Okay, so here we go. Y minus 4 equals -4 times x minus -2. Yes, +2. I changed it. But I always do the minus negative because it's a step in the process, but it is plus. Okay, now this is probably how your answer will look in the back of the book. All right, let's go ahead and solve for y so that we can graph it. Y minus 4 equals -4x minus 8. I distributed, and then the last step would be add 4. So y equals -4x minus 4. Either one of these are acceptable answers. Okay, so the last thing that we want to do is we want to graph. Do you guys want me to give you graph paper right now? Okay. Hold on just a second. Let me get my graph pulled up. Maybe. Oh no. Don't do this. Okay. It is so slow. Oh, you guys are leaving. Okay, the last step is to graph both the function and the tangent line. And you guys, the reason why you're doing this is to really get a clear picture of what's going on. So first thing that we want to graph is our first one is f of x equals x squared, which was our function. And you guys should know how to graph that pretty quickly because you just did a project on it, okay? So 0, 0, 1, 1. If I have x is 2, what's y? 4. And then you can go over to 3, 9 if you want. 3, oh, is that 9? I don't know. Okay, so you have a parabola. Okay, so this is f of x. And then you also need to graph your line. So next thing I'm going to graph, my second one, sub 2, is y equals -4x minus 4. So to graph that, you first plot b, which is your y-intercept. You go down to -4. You put a point. And then I need a slope. I always have my students write their slopes as fractions. -4 over 1. Okay, so from here, I need to either go down 4, and then which way? To the right 1. Or I could have gone up 4 and to the left 1. either way, you're creating a slope or a line with a negative slope. And if you did this really neatly, it should be tangent to your function at -2, which mine is okay. But it should be tangent right here. Do you see it? Okay. Okay, do you want to try one of these on your own, or do you feel like that covers that topic? You're good? Okay, then let's do just two more kind of small examples. The first one I found interesting, and it kind of bothers me a little bit. On this, we're going to do two things. We're going to just find the derivative. Okay, now when I say derivative, basically what I want, that's f prime of x. Basically, I'm not going to tell you to find the derivative at a point. I just want a vague derivative for the whole thing. Okay? So you guys know that f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. So again, this time I'm not specifying where to find the slope. I just want a general idea. So if I give you a function, let's do f of x equals 1 over x plus 2. Okay, so you guys were kind of going backwards. This is the first thing you learned. So you're going to say f prime of x, because I want you to get into the notation, is the limit as h approaches 0, f of x plus h minus f of x all over h. Okay, and then you can go over to the side and you can start your step 1, your step 2, and your step 3. So step 1 is to find f of x plus h. And I know this is where people usually get stumped on quizzes and tests. So instead of having 1 over x plus 2, we want 1 over x plus h plus 2. And then this one's a little bit easier. Step 2 is already found because it's right here, and step 3 is there. So now it's time to substitute. Keep writing the whole thing. The derivative, which is f prime of x, is the limit as h approaches 0. We're going to put in 1 over x plus h plus 2. That was my step 1. I'm going to subtract f of x. Remind me what f of x was again, Hunjay. Or Abby. That's fine. Go ahead, Abby. 1 over x plus 2 divided by 2. Now, I chose to do kind of a harder one because I felt like you guys needed the exposure to it. I could have done something easier. I didn't mean to. Thank you. Probably because I started thinking about what I was going to say first. Okay, now, what's the algebra tactic to deal with something like this? Common denominator. Now, somebody asked me the other day, there's just an h in here. Can I just add an h over here? You cannot do that, okay? You have to multiply this times x plus h plus 2 and do that on the top. And then over here, multiply by x plus 2 and x plus 2. Also, these are called complex fractions, so it might be a good time to not think of this as h, but think of it as h over 1. Okay, here we go. F prime of x is the limit as h approaches 0. Numerator, x plus 2. Be careful. You need to distribute a -1 to all these three things. So minus x minus h minus 2. Do not waste time distributing on your denominator, your common denominator. Just leave it. Is it okay if I change the multiplication right now? Yes. So multiply by the reciprocal. Okay, so lots of stuff going away. The x's go away. The 2's go away. This h goes away with this h. Careful, what's on top? It was -1. You know, and maybe I should write that. I'm going to undo. Let me see if it works. Okay, so the 2's go away. Maybe it's important to write this line so that you see that -1 is on the top. H's go away, and you need to hold the place with a -1. Okay, now, can I substitute? Can H be 0 at this point? Yes. So I have -1 over x plus 2 times x plus 0 plus 2. And that would be -1 over x plus 2 squared. And I'm okay with that answer. You don't need to multiply that out. This is the derivative. Now, basically, you guys, what I just did is I showed you two ways to do the same thing. If I said, find the derivative at x equals 5, you could put 5 in here and 5 in here. It's a personal preference, okay? So the way we did it the last time was we put 5 in at the beginning. But this way, you can always find a derivative and then put your point in if you want to. I'd like to give you options, but sometimes I'm afraid of giving you options. Okay, last one. It's very short. Part B, find the derivative of f of x equals 6. What is that function? A line. What kind of line? Horizontal. So we should know what the answer is. If we make a tangent to this line, and I know those of you watching the recording can't see my hands, what I'm doing, but if I make a tangent to that, what's the slope of it? 0. They're both 0. Okay, now, it's not in one point. I see the conundrum.
Unless it's like crossing it.
And they can't cross it. We still do it. Let me ask some of the calculus people. I'm going to ask them about the square root function, then I'll ask them how we consider this to be tangent. But I think that maybe the rule is that as soon as something doesn't have a curve to it, that's the only way that tangent can happen with it. Does that make sense? Kind of. Okay, so if there's no curve, then tangent is touching it in every place.
If it's touching, it would have to be the same.
Yes, it's the same line. Okay, so watch how it works out mathematically. F prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. Off to the side, f of x plus h, what does it equal? 6. You don't have an x in there to replace an x plus h, okay? So what you get for a derivative this is step 1. Sorry, I kind of forgot my steps. I know some of you really like that. Step 1 is 6 minus, what's f of x? 6 all over h. And so what happens is we get 0, well, let me write this. The limit as h approaches 0 of 0 over h. And that bothers me a little bit because I kind of envision it as 0 over 0, which you can't do, but they say that the answer is 0. And maybe that's because before you would put the limit in, maybe order of operations says that you have to evaluate that first. So really, it's the limit as h approaches 0 of 0. And that kind of makes more sense to me. Okay? Okay, here's what you guys are going to practice today. You got lots of time to get it done. Homework 11.3. It's due Friday. You're going to be snowed in May, so you'll be able to sit inside and do some math homework. Page 777. Numbers 1 through 10. Lots of vocabulary. Do your best. I know you might have to read a little bit through the section to see what they're looking for, because I know I didn't put down a ton of vocabulary, but see if you can interpret it. 35 and 37 are just find the derivative. And I would like to make this one shorter. So I'm going to write this down and then I'm going to cross one off, okay? 43, 46, 47, 49. So I will end up crossing one of these off. But I got to go look at the book and I can't walk over there. Okay? Extra credit. You need some. Maybe. I don't know. 40, 70, and 72. And that's the first extra credit that I've offered for this chapter for no reason. But make sure you do it on separate paper. Okay? And we won't turn it in until the test. Do you feel okay about it? Any questions? I'm sure you could use some time to work.